Hello and welcome to the Entertaining Physics Sports Network, EPSN. Last night, we had a grueling football match between the Seattle Kickers and Wasatch Dropouts. More on the story is Jim for some intense highlights and breakdown of the game. Jim?
Hello? Is this thing on? Hello?
Yes. Yes, it is. We can hear you. Every word.
Oh, oops. Well, yes, Bob. That was an exciting game indeed. On paper, the Wasatch Dropouts had this game in the bag with 30 shots on goal and 90% ball control. But too bad for the Dropouts. They were no match for the Seattle Kickers' superior geometry skills in scoring the only shot they had in the game. Crazy, am I right, Bob?
Yes. Yes, you are crazy, Jim.
Yep, after a game like that, you can't help but hang your head and wish you never dropped out of geometry. No siree. No one wants to be an outlier like that.
Wait a minute, Jim. What does high school geometry have anything to do with winning a soccer game?
For one thing, it keeps you in shape. Ah, but there's more to it than that, Bob. I've been dying to show you. Let's look at some highlights. Here in the opening minutes of the game, the dropouts really put some pressure on the keeper, shooting 15 shots on goal. But all of them, look at this, all of them, all straight at the keeper. Bob, here's where geometry comes into play. Let's take a closer look here at this last shot from the dropout. Okay, freeze this picture. Now before he kicks the ball, I'm going to draw some lines that show where the potential scoring angle is.
Wait a minute, Jim. What about the keeper? Doesn't he guard half the goal?
Right you are, Bob. The keeper can guard about 6 feet on either side. So I will draw another line. And now we have an angle that represents the true scoring angle. Bob, do you know what kind of angle this is?
I don't know, Jim.
This is a cute angle. Ah, very small. But we have a problem here. These triangles aren't friendly right triangles, meaning one of the sides isn't 90 degrees. Let's draw some right triangles, Bob. Oh, this is just too good. Here is the first, the second, and the third. Now let's put it all together. Now as you can see, Bob, if we can solve some of these angles in the right triangle, we can figure out what angle he needs to kick the ball at.
That's fantastic, Jim.
I'm glad you're a fan, Bob. But before we begin, we need to learn triangle lingo. First, you start at the angle you want to figure out, which is this one. Then, this side is the opposite side. This one is the adjacent side. And the long one is the hypotenuse. To figure out what the angles are, all we have to do is use our good pal SOHCAHTOA. Sine of the angle is equal to opposite over hypotenuse. Cosine of the angle is equal to adjacent over hypotenuse. And tangent of the angle is equal to opposite over adjacent. Now all we have to do is pick one and solve for the angle. Let's use TOA because we know the opposite and adjacent side lengths of our triangle.
But how do we solve for the angle, Jim?
Bob, to solve for the angle, we punch in the inverse tangent of the opposite over adjacent into our calculator. Punching in the numbers, we will get 45 degrees for the first triangle, 51 degrees for the second, and 55 for the third. Now, all we have to do is do some adding and subtracting to get all of the other angles. The first angle is 10 degrees, and that's the angle of the goal. Then the goalie guards 6 degrees, so that leaves us with 4 degrees to actually score. Wow, that is small. No wonder the dropouts couldn't get it in the net. Right you are, Bob. Now, let's take a look at the kicker's angle. In the last minute, the kickers ran down the middle of the field and scored. Can you figure out their scoring angle? Let me give you a hint. If you draw a line down the middle, you can make all of the right triangles that you need. The angle in the big right triangle is 12.5 degrees. And the small right triangle that the goalie guards is 6 degrees, which leaves 6.5 degrees on either side to score, which turns out to be 13 degrees of possible scoring angles. Woo! Go geometry! Go kickers!
Thank you, Jim. That concludes our wrap-up for today. Till next time, we cover the sad physics of missed field goals.